Good evening and welcome to this PSPICE tutorial for EE346. This is intended to be a supplement for students after they have completed Lab 1. Let's start with the basics. The first entry in every line determines what the rest of the line will be about. If it starts with an asterisk, the line will be commented out. Lines that start with a character declare a specific type of component. Also, the first line of every file must be a comment. This list shows how to declare some components useful to this class. In order to name a component, you must first enter the variable corresponding to the component, followed by the rest of its name. Each individual part must have a unique name. Now let's discuss the syntax of placing parts in a circuit. To place a part, you must enter the name, then the positive terminal number, then the negative terminal number. If the component has any complicated parameters, you must create a model name and on a separate line define those parameters. For simple circuits, you can just enter the characteristic value. For example, take this resistor. It's named R1 and goes from node 1 to 0 and has a resistance of 100 kiloohms. Capacitors and inductors are also defined the same way. For more information about additional parameters, see the reference manual for details. When defining voltage sources, you must first decide between AC or DC. If it's DC, you can enter the voltage after the node numbers. If it's AC, you must enter a stimulus, such as a sine wave. The different types of possible stimuli are found in the reference manual, along with their syntax. In order to get PSPICE to generate the type of characteristic curves you're looking for, you must perform a sweep. The .dc command sweeps through a range of DC voltages on a given voltage source. The .tran command shows the time evolution of a circuit which has an AC component. Now, let's look at parts that require specific model parameters. Here are two diodes in series that go from node 1 to ground. They are both defined as using model DS. DS is defined using the .model command and is said to be a diode with a saturation current of 1 picoamp. Transistors must be declared using 3 nodes. The one in this example is an NPN with parameters listed as shown. There are many more parameters listed in the reference manual. If a parameter is not specified in the code, it will automatically use the default value, which is also found in the manual. JFETs are defined in a similar way. This one is an N-type model. The names of the different types of models are listed under JFETs in the manual. This concludes the syntax tutorial, and next we will show you how to simulate an example circuit.